Okay, previously we have already learned how to charge. Okay, we have learned how to charge a neutral body by rubbing. That means through friction, like this cloth rub against the rod, and because of electron gain or loss, like for example in this case, the cloth gain electron because because it gain electron, it becomes negatively charged, and the rod loses electron, it becomes positively charged. So we concluded that a neutral body, is charged by gaining or losing electron through friction. Okay, so this was where we ended last lesson. And then in this new lesson, we we will learn about what is charge distribution or electrostatic induction. The interaction is between a charged body and a neutral body. Okay, previously it was turning a neutral body into a charged body, but now if I bring a charged body like this diagram, you look at this diagram, how a charged body, how a charged rod, positively charged rod, when it brings, when it comes near to a piece of neutral paper, a neutral body, how will the charges in the neutral body behave? I would like to show a couple of clips uh, to for you to see the effect first. Okay. Now, if you look at this first video clip, this first video clip. So what this person demonstrate here is he is going to rub this glass container and turn it into a charged body. When he bring this charged body near to this neutral body, let's see what happens. Okay? A charged body brought near, a charged container brought near to all these neutral styrofoam pieces. What happened? What happened is that the styrofoam pieces, which is the neutral body, get stuck to the charged body. Okay, just look at the effect and understand the effect first. Later on, we will learn how to explain this effect. Okay, between a charged body, this glass container, and the neutral body, the styrofoam pieces, when they come close to each other, see what happened, and we will have to learn how to explain that. Next, the next demo. Let's look at the next demo now. Okay, now look at this. Um, Now he is going to use the cloth to rub this a plastic pipe. Okay, this plastic pipe, and turn this plastic pipe into a charged body. And then he is going to bring this charged body, this charged pipe, near to the neutral can, the neutral body, and see the effect. Let's see the effect. He is going to start showing by not charging first. Before charging, you see no effect. See. Okay, did you hear that? Because both body are neutral, there is no effect. So now he's going to charge up this uh, plastic pipe, PVC pipe. Now bring here. So you see that the neutral body gets attracted to the charged body, the PVC pipe. Just like just now, the container, the glass container that has become charged would attract the styrofoam pieces, the charged body, the neutral body. So a charged body will always attract a neutral body. Okay. Now let's watch another clip. This time is between running water and the charged balloon. So we are going to create a stream of water first. Let's see. See, she is going to charge the pipe by rubbing it against her hair. So the pipe become charged. Then when she bring the pipe near to this neutral stream of water, let's see what happens. See, the stream of water curve to the side of the charged pipe, showing that a charged body will always attract a neutral body. Again, all this we have to learn to explain why. It has got to do with the charge separation on the neutral body. So I go back to the notes now. If you look at what happened next in my in this apps, remember I'm going to charge this balloon by across the rubbing it on the sweater. So this balloon gain electrons and becomes negatively charged, whereas the cloth, the sweater loses electron, loses the negative charges and become positively charged. So there is attraction between this positive and negative. That's why the balloon attracted to the sweater. That was what we learned previously. But right now, I'm going to bring it near to the neutral wall. Let's look at the wall on the right side. Let's look at the wall at the right side. The wall is made up of equal number of positive and negative charges, so the wall is neutral. And I'm going to bring this negatively charged balloon near to the wall. See what happens. See, this is called charge separation. You know, see, why did the electron move to the right? Why did the electron in the wall move to the right when my balloon bring near? It's because the electrons in the balloon repels the electron in the wall. So the electrons in the wall get repelled and move to the right. But the left side of the wall becomes positively charged because the electrons has gone away. So the left side is uh, what remains on the left side is the positive charges. So what happened here is because of attraction, therefore the balloons get attracted to the wall. Okay, so a neutral body will always get attracted to a charged body because of this charge separation in the neutral body. So this lesson we are going to talk only about that. Okay, now everything is back to the notes. So back to the notes here. So in the O level, you will always be asked when a charged body is brought near to a neutral body, just like this paper, the charge will separate this way. You can draw it in your notes. The charge will separate this way. Wait, okay, so you can draw the charge separated. Okay, at first they were all together, plus and minus were together, but because this positively charged rod is brought near, the electrons are attracted to the top because unlike charges attract. And then that will leave the bottom with just positive charges because the electron has moved up, so leaving the positive charges below. So this is the way to explain. Because O-level question like to ask you to draw, then explain why the charges are separated in this way. Okay, so this is the way we explain. Okay, if you look at explain why, what charges are here on top. They are negative charges. Explain why. Explain why. Okay, the reason is because the electrons on this paper are attracted to the top. They are attracted to the top. Why? Because unlike charges between this rod and the electrons, unlike charges attract. The law says that unlike charges attract. You must always state the law. Unlike charges attract. Okay, but why are there positive charges at the bottom? Now you cannot say because positive charge of the rod repel positive charge in the paper and push it downward. You cannot say that because positive charges cannot move. The way to say is the positive charges are at the bottom because the electron has been attracted to the top. So that leaves the positive charges behind at the bottom. So the way to explain this is the positive charges are left, positive charges or protons are left at the bottom. Remember, you cannot say positive charges are repelled to the bottom because positive charges don't move. Only the electrons move on the atom. Okay, so that's one example of an O-level question. Now, next, they will ask about the behavior. Explain behavior. Why do the paper jump up and get stuck to the charge rod? Like the demo you see, the first demo that you see. Why did the paper jumps up? If it jumps up and gets stuck, it must be because of what law? The law, it must be because of unlike charges attract. So the way we say is, since unlike charges attract, put the law in first. The negative charges on top of the paper, yeah, the negative charges on top of the paper are attracted by who? By the positive charges on the rod. By the positive charges on the rod. Okay, by the positive charges in the rod. So write this down in your notes. This is the way we explain. So this chapter, in this lesson, we only talk about how charges separate and why they separate this way, and then the behavior. Why did the neutral body, the neutral paper gets stuck to the rod, the charge rod, is because of the attraction. Unlike charges attract. Okay, between the paper, the electrons on the paper, and the positive charges on the rod. The attraction caused it to get stuck. Now we try the next question, the next demo that you saw just now. The stream of the water. Why did the stream of water get attracted to the balloon? Okay, the negatively charged balloon. I bring it near, the stream of water will curve towards the balloon. Now, before you can explain, you are supposed to draw the charge distribution. How did the charge get separated on the water? Because the water is the neutral body, it has both positive and negative. But how did the charge separate? Okay, so you can draw this way. For it to be separate, the left side must always become the opposite. Opposite to who? Opposite to the charged body. Just like the paper, the top side become negative. Why? Because it must be opposite to the charge on the rod. Since the rod is positive, the top end that is nearer to the rod must be the opposite charges that is negative. So now, this stream of water, you will have to draw this way. Okay, you will have to draw it this way. All right. The positive is on the left side of the stream of water, whereas the negative side, the positive side is on the left side of the water, while the negative charges are on the right side of the water. Why? Because the the side that is nearer to the charged balloon must be opposite charges. Only then they can attract each other. Okay? So since the balloon is negative charge, the left side, which is nearer to the balloon, must become the opposite charge, which is positive. Then you draw the equal number of negative on the right hand side. See how many positive charges there are. 1, 2, 3, 4, 5. Then the right side will also be 1, 2, 3, 4, 5. Because it started with equal number of positive and negative charge on the neutral body. So when they separate, they must separate also equal number. But one side, left side is positive, right side is negative. Okay, now how do we explain? Remember, after the drawing the separation of the charges on the water, now you must be able to explain why the charges in the water are distributed in the way you have drawn. Why the left side is positive, why the right side is negative. After drawing, you must always explain by looking at the negative charges. Looking at the negative charges. So look at negative charges because only the electrons move. So why did the electron go to the right side? Why did it go to the right side? Okay, because it has been repelled by the electrons on the balloon, okay, it was repelled. That's why it get repelled to the right side. Okay, we always start by explaining the electron on the neutral body. Why did it go to the right side? Because they are repelled by the electrons on the of the balloon. That's why it get pushed to the right side. And why did it get pushed? Because light charges repel. Light charges repel. So the way we explain is this. Since light charges repel, the negative charges on the water or the electrons on the water are repelled to the right side. And because they all move to the right side, it leaves the positive charges on the left side of the water, leaving the positive charges on the left side of the water. See, the separation is because the electron move away. Let's compare with the answer previously. How is it different? Previously, it was the charged body was positive. When you bring it near to this paper, the neutral body, the electron get attracted to the top. So the way I answer now is by attraction. Since unlike charges attract, the electron move is attracted to the top. Okay? Whereas when I answer this way, this charged balloon is negative. And in my drawing, my electrons go to the right side of the water. So I have to say repel this time. And since light charges repel, the electron get repelled to the right side. Okay, move to the right side, leaving the positive charges on the left. So the way we explain depends on the charged body, what kind of charges it is, and then you draw the diagram. After you draw the diagram, the charge separation, then you talk about how the electron move. If the electron move by repulsion, then you have to start your answer with since light charges repel. If the electron move by attraction, because it move up to the top due to the positive charges on the rod, then you have to start your answer by since unlike charges attract, then the positive charges are left at the bottom. This one is since electrons are repelled to the right, therefore the positive charges are left on the left side. Okay? Now, why did the water, now the behavior, why did the water tilt towards the balloon? Why did it move towards the balloon? Because of attraction. Attraction between these two. That's why it moves towards the left. So how is this attraction? How did this attraction comes about? It's because of the attraction between the positive charges on the left side of the water and the negative charges of the balloon. Okay, so the way to answer this time is since the unlike charges attract, the positive charges on the water are attracted to the negative charges on the balloon. Okay, I hope you get the gist of this in this lesson. Whatever the case, whether the charged body is negative or whether uh, the charged body is positive, the end result is the neutral body always get attracted towards the charged body. Okay, that's why in conclusion we say a charged body always attract a neutral body. It always attract a neutral body. All right. So that's the end of this lesson. Thank you.